Solving a quadratic equations can be difficult, but luckily there are several different methods that we can use depending on what type of quadratic that we are trying to solve. The four methods of solving a quadratic equation are factoring, using the square roots, completing the square, and the quadratic formula. Solving quadratic equations by factoring. An equation containing a second-degree polynomial is called a quadratic equation. For example, equations such as 2x squared plus 3x minus 1 equals 0 or x squared minus 4 equals 0 are quadratic equations. They are used in countless ways in the fields of engineering, architecture, finance, biological science, and of course, mathematics. Often, the easiest method of solving a quadratic equation is factoring, means finding expressions that can be multiplied together to give the expression on one side of the equation. If a quadratic equation can be factored, it is written as a product of linear terms. Solving by factoring depends on the zero product property, which states that if a times b equals 0, then a equals 0 or b equals 0, where a and b are real numbers or algebraic expressions. In other words, if the product of two numbers or two expressions equals 0, then one of the numbers or one of the expressions is equals 0, because 0 multiplied by anything equals 0. Multiplying the factor expands the equation to a string of terms separated by plus or minus signs. So, in that sense, the operation of multiplication and thus the operation of factoring. For example, expand the factored expression x minus 2 times x plus 3 by multiplying the two factors together. By using the FOIL method, x minus 2 times x plus 3 equals x squared plus 3x minus 2x minus 6. The answer is x squared plus x minus 6. The product is a quadratic expression. Set equals 0, x squared plus x minus 6 equals 0 is a quadratic equation. If we were to factor the equation, we would get back the factors we multiplied. The process of factoring a quadratic equation depends on the leading coefficient, whether it is one or another integer. We will look at both situations, but first, we want to confirm that the equation is written in standard form. Ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a is not equal 0. The equation x squared plus x minus 6 equals 0 is in standard form. We can use the zero product property to solve quadratic equation, in which we first have to factor out the greatest common factor, or the GCF, and for equations that have special factoring formulas as well, such as the difference of squares, both of which we will see later in this video. A general note: the zero product property and quadratic equations. The zero product property states if a times b equals 0, then a equals 0 or b equals 0, where a and b are real numbers or algebraic expressions. A quadratic equation is an equation containing a second-degree polynomial. For example, ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and if a not equal to 0, it is in standard form. Solving quadratics with a leading coefficient of 1. In the quadratic equation x squared plus x minus 6 equals 0, the leading coefficient or the coefficient of x squared is 1. We have one method of factoring quadratic equations. How to given a quadratic equation with a leading coefficient of 1? Factor it. First, find two numbers whose product equals c and whose sum equals b. Second, use those numbers to write two factors of the form x plus k or x minus k, where k is one of the numbers found in step 1. Use the numbers exactly as they are in. In other words, if the two numbers are 1 and negative 2, the factors are x plus 1 times x minus 2. Third, solve using the zero product property by setting each factor equal to 0 and solving for the variable. First example, factoring and solving a quadratic with leading coefficient of 1. Factor and solve the equation x squared plus x minus 6 equals 0. To factor it out, we look for two numbers whose product equals negative 6 and whose sum equals 1. Begin by looking at the possible factors of negative 6. So the last pair, 3 times negative 2 sums to 1. So these are the numbers. Note that only one pair of numbers will work. Then write the factors x minus 2 times x plus 3 equals 0. To solve this equation, we use the zero product property. Set each factor equal to 0 and solve. So x minus 2 equals positive 2 and x plus 3 equals negative 3. The two solutions are x equals 2 and x equals negative. Second example, solve the quadratic equation by factoring of x squared plus 8x plus 15 equals 0. Find two numbers whose product equals 15 and whose sum equals 8. List the factors of 15. 1 times 15, 3 times 5, negative 1 times negative 15, negative 3 times negative 5. The numbers that add to 8 are 3 and 5. Then write the factors, set each factor equal to 0, and solve. So x plus 3 equals 0. The answer is x equals negative 3. X plus 5 equals 0. And then the answer is x equals negative 5. So the solutions are x equals negative 3 and x equals negative 5. Third example, using the zero product property to solve a quadratic equation written as the difference of squares. Solve the difference of squares equation using the zero product property of x squared minus 9 equals 0. Recognizing that the equation represents the difference of squares, we can write the two factors by taking the square root of each term, using a minus sign as the operator in one factor and a plus sign as the operator in the other. Solve using the zero factor property, again, of x squared minus 9 equals 0. So x minus 3 times x plus 3 equals 0. X minus 3 equals 0. The answer is x equals positive 3. And x plus 3 equals 0. And the answer is x equals negative 3. So the solution are x equals 3 and x equals negative 3. Factoring and solving a quadratic equation of higher order. When the leading coefficient is not 1, we factor quadratic equation using the method called grouping, which require 4 terms. With the equation in standard form, let's review the grouping procedures. With the quadratic in standard form, ax squared plus bx plus c equals 0. Multiply a times c. Second, find two numbers whose product equals ac and whose sum equals b. Third, rewrite the equation replacing the bx term with two terms using the numbers found in step 1 as coefficients of x. Fourth, factor the first two terms and then factor the last two terms. The expressions in parentheses must be exactly the same to use grouping. Fifth, factor out the expression in parentheses. Sixth, set the expression equal to 0 and solve for the variable. Fourth example, solving a quadratic equation using grouping. Use grouping to factor and solve the quadratic equation of 4x squared plus 15x plus 9 equals 0. First, multiply AC. 4 times 9 equals 36. Then list the factors of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. The only pair of factors that sums to 15 is 3 plus 12. Rewrite the equation replacing the v term 15x with two terms using 3 and 12 as coefficient of x. Factor the first two terms and then factor the last two terms. 4x squared plus 3x plus 12x plus 9 equals 0. X times 4x plus 3 times 4x plus 3 equals 0. 4x plus 3 times x plus 3 equals 0. Then solve using the zero product property. 4x plus 3 times x plus 3 equals 0. 4x plus 3 equals 0, then the answer is equals x equals negative 3/4. X plus 3 equals 0, then x equals negative 3. So the solution are x equals negative 3/4 and x equals negative 3. The last example is solving a higher degree quadratic equation by factoring. Solve the equation by factoring of negative 3x cubed minus 5x squared minus 2x equals 0. This equation does not look like a quadratic, as the highest power is 3, not 2. Recall that the first thing we want to do in solving any equation is to factor out the GCF, if one exists, and it does here. We can factor out negative x from all of the terms and then proceed with grouping. Negative 3x cubed minus 5x squared minus 2x equals 0. Negative x times 3x squared plus 5x plus 2 equals 0. Use grouping on the expression in parentheses. Negative x times 3x squared plus 3x plus 2x plus 2 equals 0. And the negative x such as 3x times x plus 1 plus 2x plus 1 equals 0. And then the result is negative x times 3x plus 2 times x plus 1 equals 0. Now, we use the zero product property. Notice that we have three factors. Negative x equals 0, and then transpose, it will become to x equals 0. 3x plus 2 equals 0, x equals negative 2/3. X plus 1 equals 0, and then transpose, it will become to x equals negative 1. The solution are x equals 0, x equals negative 2/3, and x equals negative 1. So that's all for this video about solving quadratic equations by factoring. Again, I'm Rorela Intero, B is in Math 1B.